All right, so the next thing is called a frequency distribution, where we're going to talk about frequency and go into different parts of it so we can see the actual tables and stuff that goes on. So a frequency, if you think of the frequency that you do something, or you think about the amount of times you've done it, right? So like the frequency of going to the bathroom in a day. How frequent do I go to the bathroom? Or how frequent do I play video games in a week? That type of thing, how many times you do it. That's what we're talking about, frequency. So frequency is how many times the value or the number occurs in the data set. So you're filling in frequency and filling in occurs. It's your number of times. You're going to count how many times there are. Your relative frequency. The relative frequency tells us the proportion of which the category occurs in the data set. So in other words, you write this in fraction form. So it could be like out of 25 questions or 25 numbers, 5 of them are in this one. So 5 out of 25. It could be in a fraction form, it could be a decimal form, it could be a percentage form. So all that's going to come into play when we look at the numbers and see, okay, how many is in this one, how many is in that one. All right, so with this, the last part is going to be so in other words, frequency is the amount, how many times we see it. This is actually the fraction of decimal that shows you out of how many, like 5 out of how many there are in all. And then our frequency distribution talks about, hey, we're going to make a table and everything, but it sets the numbers up in a certain range. Then it counts how many numbers are in that range. So in other words, it counts your frequency. So with that part, we're going to get ready to take a look at a table, frequency distribution, where we're going to actually take a look at the relative frequency. We're going to be counting the frequency itself. So we're figuring out how many times the numbers occur in that range. And we're going to deal with numbers, again, that are in a range, as I said right there. All right, so I think that's it on this table. Nope, example 2. So let's go to example 2 here. And so we're going to actually do a frequency distribution using the data we just had for question 1. So we're looking at example 1 there. So using that same data we just had, we're going to use that. Actually using your stem and leaf plot is going to help us out perfectly with this. Because it already has the numbers counted in there, really, right? We already did that part, so it's not hard. All right, so the first thing we're going to do is we're going to determine what the range is going to be for each line. So it's always best to go by tens, but if you want to go by a different range, you can. But I promise you, going by tens will make life so much easier for you. I promise. All right, and then we're going to make a table for second. So the table's already been made for you. So you have your intervals, you have your frequency, and you have your relative frequency. Remember, frequency is how many times the number occurs in that range. Your intervals is the range from this number to this number. Your frequency tells you how many numbers are inside that range, how many times you have a number there. And then the relative frequency tells you that how many numbers there are out of all of it. So it's as a fraction. And we could change to a percent also. So we can get to that part. So again, we're going to take a look at our stem and leaf plot that we just created. And we're going to use that to help us to get rid of, or to actually use the, what's the word? We're going to find our intervals. That's what I'm talking about. All right, so if we look back at a stem and leaf plot, remember we had numbers that were between 0 and 10. That was like the 5s, the 6s, the 7s, the 1s. So our first interval is going to be between 0 all the way up to 10. So it doesn't equal 10, but it's up to 10. The next one is going to be from 10 to 20. So again, like I said, we're going to go by tens to make life a little bit easier. And this is an X right there, guys. I apologize. This is writing weird. So we go from 10 to 20. We got 20 to 30. Again, going by tens. 30 to 40. Now, the whole thing that hopefully everybody's paying attention to is on the left side, we're doing the equal to sign, less than or equal to. On the right side, we're using just the less than sign, which means it does not equal 40 on this line. We use 40 on this side. So we're looking at the numbers are between 30 and 40. So in other words, all the numbers that start with a 3 go on this line right here. Ooh, never let that happen. All numbers that start with a 30 on here. All numbers start with a 20 comes on this line. All the numbers that start with a 40 are on this line. When you get to 50, you go to the next line. So all the things that start with 50 or the 5 goes here. And I do apologize, guys. My writing is normally better than this, but I'm using this little pad thingy thing. All right, so we got 60 to 70. It's a little bit better. We got 70 to 80. We have 80 to 90. We have 90 to 100. Now, with this part, before we go further, we can stop at 100, but that means we won't get the 105 in there. And remember, the biggest number that we have is 105. So that doesn't fall between 90 and 100. That doesn't start with a 9 at all. So it means we have to go one last one so it covers that 105. So we're going to do 100 to 105. Oh, 100, sorry, 110. Sorry, going by tens. So 100 to 110. Right, so we have that range. So we're going by tens each time. But again, each line we're talking about anything that starts with an 8 will go on this one. Anything that starts with a 9 goes here. Anything that starts with a 7 goes here. Anything that starts with a 6 goes here, so on and so forth. So again, it does not equal 10 on these lines, or 20 or 30. That goes on the next one. So when we take a look at the actual stem and leaf plot, we actually already looked at the numbers, and you can kind of see, hey, out of between 0 and 10, we didn't have any numbers there, right? So we looked at that first line on a stem and leaf plot. Let's go back real quick. If you take a look at that first line of stem and leaf plot right here, there are no numbers in there. So when it comes to our frequency distribution, we got our range going on. Come on, come on, come on. Go down, all the way down. There we go. So it means we're going to put 0 right here. And then when we go to the next part, 10 to 20, the numbers that are in the teens, there were 4 numbers there. 4 numbers. If you look at 20 to 30, you count how many there were there. You should have counted that there were 3 numbers right there. When you go from 30 to 40, there were 4 numbers again. When you go from 40 to 50, there was 1 number that was in the 40s. So put a 1 there. 50 to 60, there were 2 numbers. We have 55 and 56. So there's 2 numbers in there in that range. When it came to 60 to 70, remember there were no numbers in there, so that's 0. 70 to 80, that was 0. 80 to 90 is a 0. And then 90 to 100, there were no numbers in there either, so that's 0. But then our last one, we had from 100 to 110, we had that one number of 105. So we're going to put 1 right there. Oh, that should be a 1, sorry. All right, so we have a 1 right there. So with that, that counts how many numbers. So remember, your frequency tells you how many numbers are inside of that range. So the first step is figure out the range, right? The range is out there on the intervals. Then we count for the frequency, which is how many times numbers are inside of that range. So between 40 and 50, the numbers that are in the 40s. All right, and then the last part is trying to figure out what is the relative frequency. Now, before we do that, I'm going to write this part down here. So here, if you count up all the numbers in this table, this column here, the frequency column, you will see that there are 15 numbers in all. So I'm going to write that down here at the bottom. The total frequency is 15. Remember, so that's going to help us with our relative frequency. So if we don't have that number, we really don't know what to put on the bottom of the fraction. So out of the 15 numbers, this is. So like for example, for the first one, out of the 15 numbers here, from between 0 and 10, there was 0 numbers out of the 15. So in our table here, our frequency distribution, or relative frequency, sorry, we're going to put 0 over 15. And bam, that's it. That's not hard. Now, if you want to put that in the calculator and figure out how much that is, everybody should know that off the top of their head. So that's 0%. All right, the other ones, we're going to put the fractions here. We put 4 over 15, 4 out of 15, so 4 out of the 15, 3 out of the 15, so on and so forth. All right, so you should have those fractions there. Now, if you don't want to make it to a decimal, you don't have to. You can keep it just the way it is. But if you want to do a decimal, don't forget you actually put 1 divided by 15 in the calculator. Remember, you move the decimal 2 places to give you the actual percentage. So I'm going to just give you that one there real quick. If you put it in the as a decimal, as a percent, you should get 27% there. But if you want to keep it as a fraction, keep it as a fraction and leave it right there. You are good. And guys, this is our frequency distribution right there. That's it. That's all we're talking about. Create the intervals, go by tens. So it should be the same intervals each time. You count how many numbers are inside that interval, and then you actually do the frequency. So a relative frequency by putting the frequency over how many numbers there are in all. There you go.